Alright, so let's just start off with a zeroth order hole on a PI controller. Alright, so we are actually looking forward to actually having to look at a signal of GZ. Alright, so we want to look at the transfer function in terms of the digital domain, in terms of the PI controller reacting with the zeroth order hole. Alright, your PI controller comes from PID controller, right? So your PI sorry, in the full things, KDS. Alright, this is the PID. Alright, KP plus KI over S plus KDS. This thing over here is integration because it's 1 over S. Alright, so therefore this is the integration for your I controller. This KP is for your P controller, and this D, if you happen that you have D controller, then it's D controller. But in this case, we are dealing with only PI, so let's just start with PI, which is this one over here. Okay, and then we know that this is a long chunk of thing. This is a straight path, so we have a series of stuff. So you're going to multiply zeroth order hole with a PI controller. Now zeroth order hole comes from this equation. Where does this come from? As you can see, it's this thing over here. Alright, I've been repeatedly doing three videos already. Alright, because this at first I highlight this one at first, then I highlight this one, I highlight this one, now I highlight this one, you see. So I don't know how many times I will highlight if I keep on redoing the same video. But anyway, if you want to know more about the zeroth order hole, why is it the equation over there, you can just watch l5v3. You can also watch his peripheral videos on l5v1, v2 and v4. Alright, let's continue from there. Okay, so we know that we have a series, so we're going to multiply zeroth order hole with my PI controller. So the over here is my zeroth order hole, this one, as you can see is this thing. Alright, and just keep it as G of S over here. Alright, I'll just keep it as G of S. And I'm going to multiply my G of S inside. So when I multiply my G of S inside, I would have this thing, right? So it's just multiplying G of S into 1 and to this one, okay? Just double check. Alright, so therefore I'll just somewhat rearrange. So G of S over S, alright, this done. Minus away E minus ST GS over S. So I'm just kind of rearranging stuff for you in terms of algebra. Alright, so over here this is a linear system because something minus something or something plus something. Alright, in this case it's minus lah. Sorry. So you don't have any multiplication. In multiplication then you cannot do anything. So therefore normally our first step first is we want it to be linear first. Over here when we're linear, then we can Z transform. So if I were to Z transform this dude over here, it's this one, okay, I'm gonna Z transform now. Alright, so therefore over here, I can somewhat leave it there first, okay, I leave this thing here first. And over here you may wonder why do I say that I want linear system, I want something that is something minus something, alright, or plus something. But over here this is a multiplication to something with S, alright, you see. And then you may wonder why I can Z transform straight away. The reason is because E minus ST. Alright, if it's E minus AS, then you're gonna find ways to actually separate them out. Alright, things like that. I think. I forgot. But I just remember that E minus ST, when you see minus ST, okay, with some T over here, okay, this indicates that it is a lagging Z minus 1. Okay, or in other words, K minus 1 if you were to find it suitable for you, okay. But anyway, so therefore this thing is just a lagging. Alright, so if you have a signal like this, you have a point at Z. Alright, this point over here will be your Z minus 1, this point over here will be Z minus 2. So this is K, this is K minus 1, K minus 2, etc. all the way back. I think if you remember. So these are all, so if you sum up all your past information together with your current information, this one, together you can form a somewhat a line. I think you get what I mean. So therefore this E minus ST is telling us that it is a lagging. Alright, it is a lagging. Alright, so therefore if such of the case that happens, I can just simply write as this thing over here. I just hold on a while. Alright, so my E minus ST becomes Z minus 1. So I repeat again, only E minus ST can become Z minus 1. I don't think that E minus AS or something of that meaning can become like this. Alright, it cannot become like this. Alright, so therefore please take note of that. But I may be still wrong lah, but just to take note lah. Okay, so therefore what I can do now is I see it's a common term. Alright, common term, what I can do, I can factorize n up. So I have 1 minus Z minus 1. Alright, and I put it this whole z transform behind. Okay, so therefore over here I can finally z transform my transfer function, okay, because this is just only 1 over s, right? So it's pretty much straightforward. So I'm gonna bring in my this friend, alright, my transfer function kp or plus ki over s. I'm gonna put it over here, okay, since we know that my transfer function is this one. Okay, so what I will have is, alright, so I have this thing over here, okay, and the next thing over here I can just I'll just write something like this lah, to indicate that this is this. I lazy to write, okay, so therefore I have kp over s plus ki over s square. Alright, this thing over here becomes this thing, right? Okay, so now I'm gonna use this table, alright, and if you don't know where this table comes from, it comes from your tabella transformata z, alright, you just take note of this thing. You can download, I think it's provided in your test also. Alright, so you're gonna just find my 1 over s, alright, my 1 over s is this thing over here, okay, so if I will transform, I have 1 over 1 minus z minus 1. So I'm gonna take this information, this thing over here is this thing, right? So I'll just simply rewrite it over here, alright, and then z kp s over s. S is what? I mean 1 over s is 1 over 1 minus z, this one, alright? You can also rewrite this as z minus 1, alright? You can just prove it yourself, alright? I'm not gonna prove to you, but this is the case, so let's simply rewrite it. I'll have this thing over here, okay? And you may wonder why is this thing equals to this thing, because I lazy to write, so I just write this thing as like that, okay, in case you may forgot or you didn't pay attention, or you just skip that particular part. So over here k1 over ki, the integral part, over s squared. So you're gonna use back your same stuff, alright, your table. So your s squared over here, alright, is this wing, right? So I'm gonna just take this information, alright, in this case it's z minus 1. What I can do is simply to rewrite it as this thing over here, okay? So this thing I rewrite as this one. If you don't know anything, you just, okay, I just introduce you what you can watch these videos, l5v2, l5v3, l5v4 and l6, these things, alright, these are all the transformations, the method of deriving all these things, alright, so that these videos will derive all these things for you already, okay? So I'll not go through this because I've derived to you, so I don't want to derive again. But anyway, I'm gonna just plug in this thing. I'm just gonna paste it, because 1 over s square, alright, 1 over s square is my, so ki multiplied by 1 over s square, if you z transform, is your tz z minus 1 square, right? This is something that we came from just now, right? This thing, so your 1 over s square is this one, just to double confirm now, right? So therefore I have this thing over here, alright. In full, I just copy this one, I just paste it over here, alright, and then I take this one, I copy over here also, okay, because this thing over here is simply this one, okay. I just lazy to write, that's why I just write it as like, yeah, like that. But anyway, it's this thing over here is equals to this one, alright. So because happened that you shortcut this thing, I write it like that first with shortcut method, and then I shortcut. Now I can just sub in back this shortcut into here, alright. Actually I shouldn't have done that lah, so I keep on explaining myself. But anyway, this thing over here, what is this thing? You can simply rewrite this thing as z, wow, good job, what is this, z minus 1, this is z minus 1, okay. This should be, okay, 1 minus, this is z minus 1 is 1 over z, okay. If I were to multiply z over z, which is just 1 itself, I can transform this thing as z, alright, so z over z, is it z over z? Let me see, that should be better. So your 1 over here can be written as z over z, z minus 1 is 1 over z. I can simply merge them together as a fraction, z minus 1 over z. So therefore I have this thing over here, okay, alright, and then I'll just write everything like that. Your gz is equals to this thing over here. Should have sit hz lah, okay, some transfer function Alright, so your output over here as a digital signal will be something like this. Alright, where this is your HZ. Alright, where the something, the equation, I mean the responses is all dependable on your this information all over here. Okay, so the only thing you change when you want to input your stuff is your constants kp and ki, or the z are just some constants lah. Your z, whatever thing that you want. Okay, so you can change your constants over here, or you can switch it back to Laplace and then sub in your frequency and things like that. But anyway, these are your things. If you were to just recap yourself, right, actually inside your book lah. Okay, so I'll somewhat prove to you that we have come over here. If you don't believe me, I'll just copy paste this one. So I'll just copy and paste. After I copy and paste, I realize something. This thing over here, this z, is to indicate that we're gonna z transform. Alright, it's not a z at all. Okay, because you see all along we say that we're gonna z transform. We're gonna z transform this thing over here. Right, so z transform this thing's like z k or z2, whatever it is. It's just stating that it is some telling us that we're going to z transform this thing. It's just an indication. It's not a value at all. Okay, so over here, this whole thing is consider your z transform onto the transfer function. This thing over here is not z at all. Okay, please take note. It's just indicating that you are z transforming your g of s over s. This thing is just only indication. Okay, so later on I keep on derive. I actually forget to cancel it out, damn it. So yeah, so over here up till here, maybe not here yet, maybe let me see, over here. Okay, this is where the point I officially z transform this whole thing. Okay, and therefore when I officially z transform this whole thing, alright, they actually changed to z already, the s's. Wait, your this s over here, I actually switch it to your these things over here, right? So I've officially z transformed everything into here. Okay, you may find it weird, or you may find it what the hell. I just want to indicate to you again, if this doesn't ring a bell. Alright, at first we have these things over here. Okay, we go through all the steps, multiplying the transfer function, okay, your pi, and then we say that we want to z transform, but we just leave it as this form, you see. So I'll just z transform, or you can say that this is the Laplace transform, whatever. Alright, it's similar to Laplace, but in terms now we are just capital Z, that's all. It's different from the Z that we have, that is from here. It's different, okay? It's just indicating that we are gonna transform this thing. Alright, so along the way up till here, then we start to transform, right? This is why over here this z is gone already, because we have finished transformation. I hope you get what I mean, because in tests you may also accidentally input this z. So instead of redoing the whole new video, I'll just also imply to you that this z over here, please be careful when you z transform everything, you're gonna have this thing over here. Alright, instead of having this thing. Because over here this means what? You're gonna z transform this thing again. Cannot be, right? Because you already z transform this already. You already have z's all over here. How can you z transform again? I think you get what I mean. So therefore, hopefully you get what I mean. If not, then I am sorry about that. But anyway, up till here, okay, so I'm gonna remove all the z lah. Okay, because these are all indication that I'm gonna transform, but I've already transformed. Why should I transform again? You know. So therefore, up till here, I have all those things. Alright, so therefore my z minus 1 over z is this one. My this thing over here is this one. Okay, so kind of be careful about that. So if you were to multiply them all together, you have this thing. I'll not go into that lah, but if you're free, you just own self do. Okay, so therefore this is it for this 0th order hole on your PI controller. Okay, so if you're the PID, please make sure that you're going to include your your constant d multiplied by s. S is differentiation, 1 over s is integration. Alright, so therefore I shall see you in some other days.